Good morning. Myself, Pramod Ganjewar. I am here to present my paper on food monitoring using adaptive navy-based prediction in IoT. My co-authors are Mrs. Barney S. Sanjeev Var, Santosh Sonawal. I am a research scholar in Satyabhavan Institute of Science and Technology, Dean to the University Chennai, and working as assistant professor in School of Computer Engineering and Technology, MIT Academy of Engineering. Agenda of my presentation is like this. First, I will talk about introduction, motivation, objectives, related work, proposed work, then system architecture, implementation, output of the system, result analysis, conclusion, and this presentation will ends with references. Uh, in the introduction, my topic is focusing on food monitoring. I'm taking the help of Internet of Things, and I'm using the methodology as prediction using images. So for that purpose, I have divided this introduction into three steps. So first, what is the need of food monitoring? Now, when excess food get produced, we need to procure it for future use. And for procuring it for future use, we need to store it in cold storage. And in the cold storage, when that atmosphere needs to be monitored, and that atmosphere should be suitable for that food. So for that purpose, we need to continuously monitor the environment in the food, and that environment may be good and that may be bad. When that environment in the food storage is bad for the food, then we need to convert it from bad to good, and when it is good, then no problem. So that food will be procured and can be utilized in the future. For that purpose, food monitoring is important, and to avoid the losses of the food that we are knowing. Many are there; those are not getting um, their food, and if excess food is getting uh, if excess food is getting spoiled, then no use of that. So we need to, it's our duty to save that food. And here, Internet of Things is one of the solutions for this, because it allows us to interface many devices in that system, and that devices can be used for communicating or for the uh, for performing or making it on and off with the help of the decision came from the algorithm what is implemented. And here for that prediction, I'm going to use navy base, which is modified, and the modified in the modified algorithm we added the adaptation, and that's what the main methodology used in here is adaptive navy base. The motivation is that environment monitoring in cold storage is somewhat difficult with manual method. Second is, as in the manual method, everywhere operator is there. This is operator based system. So operator will decide what temperature to keep, how to maintain the environment in the cold storage. And as they are not using the smart devices, so manually that person should be there for 24 by 7 for the purpose of monitoring. You cannot, no, at least one person, one representative should be there. Objective is to avoid food spoilage, to maintain suitable environment in the cold storage, to use smart devices so that interaction with that cold storage from outside also can be handled, to use prediction for accurate decision making. These are the objectives of my paper and related work. Now in the related work, now I have studied some of the offline food monitoring systems, then some of the IoT based food monitoring system, then so in the, some of the methods they analyze the data whatever is collected from the food monitoring system, and from that and that can be used for future decisions. Similarly, manual and sample based screening can be done to check the quality of the food. Now, in the proposed work, as we are knowing, this is the Navy-based formula, and which is used for calculating the posterior probability. And posterior probability will help us to predict the decision. And here, for that purpose, same posterior probability is used for uh, calculating the class, that is class may be bad or good, that and bad and good is the environmental condition in the cold storage, whereas this temperature and humidity is monitored, and from that the atmosphere in the cold storage or environment in the cold storage will be decided, predicted as good and bad. If it is bad, then whatever devices were connected in the system, that will be switched on to convert that bad to good. And for that we need prediction whether the environment is good or bad. If it is bad, in that case we can use that. And how to make it that good to bad, so for that purpose that IoT can be used. Now, the system architecture. In the system architecture, as I told you, I have monitored temperature and humidity in that cold storage, which is connected to Raspberry Pi, and whatever data is collected, that is through monitoring system, it will be sent to cloud, and from that, for purpose of the data analysis, and to decide whether it is good and bad. And this is the flow. We need to check the value. If the whatever values are sensed, and depending upon that, if atmosphere is good and bad, then if it is bad, then it will switch on that fans and other necessary devices to convert it from bad to good. So this is the flow of the system. And in the implementation, that is first, that is the table will talk about the components which we have used in this system. The components are Raspberry Pi, relay, fan, and DST11 sensor. In the second, the all the sensors which are interfaced to that Raspberry Pi is shown, whereas in the third, that system is connected to the laptop or the server, and the menu, we can say GUI is shown here. And in the third, that is fourth, here the output of the system can be seen with whatever temperature, whatever value, what is the value of temperature, what is the value of humidity. This is required to decide whether atmosphere is good or bad, and if it is bad, so it will make that fan on to convert it from bad to good. Next is these are all the system is implemented, and the output, graphically output is shown in this way. Now here, if the dot is green dot is in green, it means that is good values, and red values represent that values or the class predicted is bad. But in some of the cases, as nothing is accurate, so here the system is some of the dots, uh, green dots are there in the red zone, and some of the red dots are in the green zone. So that is the error in the system. So here, first diagram will talk about the training set, and second diagram will talk about the test set. Now here, this is just bifurcation of the good prediction and bad prediction environment of that is bad environment and good environment, and that is just bifurcated. Red represent danger, means it is, these are the bad conditions for the cold storage or for that food, and green represent good condition for the cold storage. Next, these are the result analysis. So here in the training set, 15 values are considered, whereas in the test set, 8 values are considered. Out of that 15, that values, now these are the predicted class. So some temperature and humidity sense, depending upon that temperature is, sorry, class is predicted. That class is good or bad. So out of 15 values, green in green zone, it means that is good values. In that, whatever values are captured. Some, that is, sometimes atmosphere is bad, so red in red. So that 6 values out of that are so red. That is, it means that it is that atmosphere at that time, at that moment is bad. whereas some green value may be in the red zone, so such values are 5, and red in green zone, so such values are 0. So here actual in green and red in red is will help us the accuracy. All the dots should be in this range only, then we will get the 100% prediction. But here some of the green zone in a red means some error is there. So here total bifurcation accuracy of the prediction is 66%, and inaccurate data is 33%. So if we make it add it, so it will become 100%. So this is for using navy base. Similarly, this adaptive navy base is also taught here. Now in the when we use adaptive navy base, that is proposed algorithm, now here number of predictor values in red zone are more. Okay, so here error as compared to previous step got reduced. So here from 66 to accuracy it get improved from 66 to 86, and because of that error also will get reduced. It means we can say that with respect to the basic navy base, the implemented system gives more accurate result as compared to first one. That is 20 to 25% of accurate result will be given by this. And next here, whatever I have told you, that is similar case is implemented on test set. So this is a result whatever we have collected to find out the performance of the implemented system. And same thing here, result analysis shown with the help of graph. Here in the first graph, the comparison of again training set and test set. In the training set, that is maroon line or red line, we can say that is the adaptive navy base. In both the case, correct prediction and wrong prediction. Correct prediction is again more than the navy base using adaptive navy base, and wrong prediction is less than the adaptive navy base. Same case is shown here. So in both the cases, the accuracy is more as compared to navy base, and uh, wrongness is again less as compared to navy base. So we can say that the implemented system is more accurate uh, as compared to uh, navy base. So here in test case we have got the result 25% more performance as compared to navy base, and in the training set we got 20% performance more performance as compared to navy base. So here as uh, this instead of in the I have told you some of the drawbacks of the manual system. In the manual system, operator should be present there, and always he need to monitor the environment in the cold storage, and accordingly make changes in the environment with system. But if we use smart devices with the help of IoT, and this algorithm will predict the value, and if value is bad, so that decision can be taken, and system will send the alert to make to switch on that fan, so that uh, the atmosphere will get converted from bad to good. So this is just conclusion of this my paper, and I have used these many references in my paper. So here with this I will end my presentation. Thank you. Any questions? Thank you. Thank you. Thank you.